Okay, we're starting a new unit of trigonometry, and we're going to start with properties of similar triangles. So the first thing I want you to know is what congruent means and what similar means. So for congruent figures, that means that it's an identical shape. So it has to be the exact same shape. So if we're talking about a triangle, then you have to have another triangle shape. It can't be a triangle and a hexagon. Those are not congruent. Congruent means that it's exactly the same. So identical shape, and it also has to have the same size. Okay, so they're completely identical. Similar figures, however, are slightly different. So you have identical shapes. So that's the same. However, it's different sizes. So they're not identical. They have different sizes, but the shape is still the same. When you're dealing with similar figures and congruent figures, you have to understand and relate it back to angles and sides. So when we have a congruent figure, you have to know that the corresponding angles are the same, because it's identical. Congruent means exactly the same. And same thing for the side lengths. The side lengths will also be the same. Now, in similar figures, corresponding angles are also the same. However, the corresponding side lengths are different. Okay? But there's a ratio between these, and that's what we're going to work on. So the side lengths are different, but the angles are the same. So that being said, those little definitions, we're going to start this example and see what this information is good for. So we have to identify a pair of similar triangles and explain why they are similar. So I'm hoping that you can see that there are two triangles within this diagram. There's one triangle that is XNP. Okay, so that's right over here, XNP. So triangle X and P, and there's another triangle right over here. Okay, now you can't just put the letters where you want, wherever you want. So you can't just say that triangle XNP is a triangle and another triangle, let's say ETX. You have to be careful where you put the letters. Now, I know that may sound a little bit confusing, but if you start with XNP, you have to make sure that in the first triangle, the first letter relates to the same letter as the second triangle. So for example, in the first triangle, X is the same in triangle 1 as it is in triangle 2. Now, if I went with N as the second position, N is right over here. So I have to figure out where the peak of the other triangle is, and it's right up here, so it's E. So N and E have a relationship. And then at the end, if you put X, N, and then P, then in triangle 2, it'll be X, E, and then T. Now, I picked that order. It doesn't really matter which order you go in. So you can use a completely different order, such as triangle NXP. So if I start with triangle NXP, then I have to go ahead and switch a couple things here. So we know that side N, okay, N relates back to angle E. So N and E have to be in the same spot. If I do X, X has to be in the same spot as the other X, since they share that common angle. And then P has to relate back to T. So if you look back up here, what happens is that you've got X always with X, just like X over here is always with X. So it doesn't matter which position you put it in, as long as they're in the same position. So for example, in my first scenario, I've got X in the first position, which means in triangle 2, X has to be in the first position also. In scenario 2, I have X in the second position, and X has to be also in the second position for the second triangle. Now, same thing goes for the other letters. If you look at N and E always have to be in the same position. So in scenario 1, N and E are in position 2, and in scenario 2, N and E are both in position 1. So they have to be in the same position when they are similar triangles. So there's another scenario here where the x is in position 3. So we're going to go ahead and write that one down. So triangle, let's put the x in position 3, which means the x in triangle 2 also has to be in position 3. And then we could put any other letter at the front. So I'm going to go ahead and put P this time. And P relates back to T, so I have to make sure that P and T are in the first position together. And then there's only an N left, and N has to be in the same position as E, just like everywhere else, okay? Now, you have to be very careful that when you're showing these triangle statements that we call them, that you pick one of the 3 scenarios. You don't have to draw all 3 scenarios. However, you have to make sure that when you label one triangle, that all those letters correspond to one triangle. You can't mix them up. So for example, you can't say that triangle XNE. Like XNE will not work. So again, when you do your work, you have to make sure that it's triangle an X, an N, and a P. Okay? On the left side. And then for the second triangle, it's triangle X, E, and T with those letters that can be rearranged as well. So you have to be very, very careful. So now that I've done these 3 scenarios, I can go ahead and put equal signs in between because they are similar triangles. They are the same shape. Both are 90-degree triangles. So we can write a reason here. So just underneath, I'm just going to go ahead and put a reason. Both are 90-degree triangles, 90-degree angle triangles. So they have the same shape. However, they're not congruent because they don't have the same size length of sides. The side lengths are different. And you can see it that this little side over here is clearly shorter than this side here. But they are both similar triangles. So when you realize that they are both similar triangles, that's because both are 90-degree angle triangles. Both have 90 degrees. So you can write that as a reason. Both have 90 degrees. And a third reason is because all 3 pairs of angles are equal. All angles are the same. So those are the reasons why they're similar triangles. Okay? So if we know that it's a similar triangle, we have to put the similar angle statement. And at this point, it doesn't matter which scenario you pick, either scenario 1, scenario 2, or scenario 3. But to write a similar angle statement, this is how you write it. So I'm going to go with scenario 1, which is triangle XNP. And to put that it's similar, you do this little symbol here. It's just like a little curve. Nothing different. Just don't put the equal sign. So it's similar to a triangle. I just have to go up to look. XET. Okay. So you have to make sure that you pick one of these statements and that you use this little symbol right here to show that they are similar angles. And this is called a similar triangle statement. So if I ask you for a similar triangle statement, this is what I'm looking for, and there are 3 different ways of expressing it. Okay, this example is slightly different because your triangles are placed slightly differently, and they're wondering if the 2 triangles in the diagram are similar. So we have to prove and explain our reasoning if we think they are or if we think that they're not. So in this case here, I take a look at both triangles. There's triangle ACB. So triangle ACB, and there's also another triangle, but I have to be careful as to how I write it. So if I started with A, I have to make sure that I start with the same angle as A. So I find that one a little bit more difficult. Here, because you have opposite angle theorem going on in here, you know that angle C is equal to the other angle C. They share a common angle, and that common angle is the C angle. So I just want you to realize that there's an opposite angle theorem here, and it's with angle C. So angle C is equal to the other angle C. So no matter what, the C's have to be in the same position. Now, in this case, it looks like there's a 90-degree angle. You have to just be careful. If it's not marked, we can't assume, but it looks like it's a 90-degree angle, so we're just going to go ahead and say that it is. And so angle B which is in the third position, is similar or the same as angle D. Okay, so B and D have to go also in the same position. And I leave the other one in the end, so that means that A is in the first position, which is equal to angle E. And those are just for the angles. The angles in similar triangles are the same. So I'm just going to go ahead and write that they're similar. I might change my mind in a little bit, but there are some reasonings behind this. But to show that they are similar, you have to show that the sides are proportional. So remember when we said at the very beginning up here, how in similar figures, corresponding angles are the same. We just proved that. But corresponding side lengths are different. They're different, but like I said, there's a relationship between them. And the relationship is that they're proportional. So we need to show that the side lengths are proportional. So in order to do that, we're going to go ahead and put the sides as proportions, as ratios. So in triangle ACB, there are 3 sides. And the way I look at it, I always start by looking at side, the first one, so AC. So if I write down AC down here, AC is proportional to the first 2 letters in the other triangle. So if I use the first 2 letters in the first triangle, I go with the first 2 letters in the second triangle. Now I do it that way, but you can also go to the diagram and say that AC is proportional to CE. Okay, but it can't be actually CE, it has to be EC. If you write CE, it's in the wrong direction. You have to make sure that your letters are written in the proper position. So that's why I always go back to these, the similar angle triangle statement, so that I know my letters are always in the correct order. So then I'm going to move along and put the other 2 sides. So if I go ahead and figure out another side, so in triangle ACB, there's side AC, but there's also side CB. So if I go down here and I show you, oh, that's not CB, sorry. CB is over here. So if I write that CB is proportional, that's the second and third position. It's proportional to the second and third position in triangle 2, which is CD. And then the third side would be AB. So we haven't done AB yet, but AB I just drew earlier, and AB is proportional. AB is proportional to, if you take a look up in your similar angle statement, A is in the first position and B is in the third position. So it's proportional to ED. And if we take a look at that to make sure it makes sense, we've got AB at the bottom here, which is proportional to DE, which makes sense. But it's not DE, it's ED, just because of the positioning of the letters. So again, go back to your similar angle statement to be able to understand that. So now that I have that, I can fill in a couple values. So if we go ahead and do that, we can see that side AC is equal to, AC is 5 meters, so I just put a 5 here. EC, which is the other triangle, EC is equal to 25. So we need to prove that these sides are proportional. Okay, so if they're proportional, all of these should be the same. So CB is equal to 3 meters, and CD is equal to 15 meters. AB is equal to 4 meters, and ED is equal to 20 meters. So all of these should be the same, and right off the bat, you can't really tell that they are. They look different to me. So what you need to do is make sure that you reduce your fractions. If you don't reduce your fractions, then you won't be able to see that they're proportional. So to reduce them, we can divide the first fraction by 5. We can divide the second fraction by 3, and divide the third fraction by 4. And when we do that, it gives us 1 over 5 for each relationship. For each side lengths, each proportion is equal to 1 over 5. Now, when you do this, you just have to make sure that the top corresponds to one of the triangles. You can't have part of your triangle at the top and part of your triangle at the bottom. So this is one triangle, and the bottom corresponds to another triangle.